We're going to be solving for the exponents with exponential equations. Okay, so it's a somewhat long title. There's a new rule I want you guys to get used to. Okay, if the bases of two exponents are considered equal, and they have different, if the bases of the two exponents are equal and their powers are different, then the rule is that these powers are equal. Okay, that sounds odd, but I'm going to show you what they mean by that. And in those cases, the base has to be greater than 0, and it cannot equal 1. Okay, so there's a couple rules that apply to it. Now, what that means here is, for instance, we have 5 to the power of x is equal to 5 to the power of 6. So when solving for x, what is x going to equal?
5.
All we're going to do is we're going to drop both the bases and we're going to set the two exponents equal to each other. Okay? So we're going to drop both bases and we have x is equal to, what's the other exponent? 6. That one's pretty straightforward. Okay? That's the idea of the rule. We're going to apply it to different types of questions. Okay? That is a question. So
So I should drop the base.
because they're the same. So let's look at the next one. Okay, so our second example here, our bases, for instance, this is 32 to the power of 1 and 2 to the power of x. These bases aren't the same. But 32 is something I can turn into a base of 2. Okay? There is a power I can use. Does anyone know what base 2 to the power of what is equal to 32?
Yeah.
No idea? Okay, then let's do a little bit of trial and error. For instance, what is 2 times 2? 4. Okay, so we're not high enough yet. Times another 2. 8. Not high enough yet. Times another 2. Times another 2. Okay, so how many 2's do we use in this case? 5. So what that means is we can turn this into 2 to the power of 5, and that is equal to 32. So we replace that with a base that is the same. Now that we've done that, we can drop both the bases. And what is x equal to in this one? Okay, x is equal to 5 in this case. Let's go down to a more difficult example. We have a question like this. Again, we have to look at the bases. This is a base 7, 49. Can I turn 49 into a base of 7? To what? What would it be? 7 squared, that's right. We know 7 to the power of 2 is equivalent to 49. So we have 7 to the power of 3x minus 4 equals 7. So we can drop both bases here. And then we have an algebraic equation here. 3x minus 4 is equal to 2. Okay? And now we have to use the algebra we learned earlier in the chapter to solve it. So we move the negative 4 to the other side. What does that become? That's right. So we get 3x is equal to 2 plus 4, which is 6. And we have 3x is equal to 6. How do I move that 3 over? That's right. We divide by 3. So x will be equal to what value here? 2. Okay. And we can double check that with some mental math. It's a little difficult. If I plug 2 in for x, that would be 3 times 2, which is 6. 6 minus 4 is 2. So we know that worked. Okay. Here's another example. We have base 3 and base 27. Can I turn 27 into a base 3? What would it be? 3 cubed, that's right. It's 3 to the power of 3. Now, but the problem is there is an x here. So think of it like we have to now multiply those values. I have to multiply this 3 times that x. So we still have base 3 for both, which is good because we can now eliminate both of the bases. And we have 5x plus 8 is equal to, what is 3 times x going to be? Just write it as 3x. Okay? Now we have to collect our like terms. Let's move 5x to the other side. When I move 5x to the other side, what does it become? Right, so we have 3 subtract 5x will become what? Negative 2x. And how do we solve for x here? Divide by negative 2. What is our x value going to be? Negative 4. Good. One last example. This will be the most difficult one. We have exponents that seem to be equations of themselves on both sides of the equation. We do need the bases to be the same. Which number can I change into the other base?
4.
Okay, how do I change 4 into that?
4x squared.
Okay, so 2 squared gives us 4. So, we take that 2, and that 2 needs to be multiplied by what was originally there. So it'll be 2 times 3x minus 1. Where we have 2 times x minus 5. So both of the bases disappear. We have 2 times x minus 5 is equal to 2 times 3x minus 1. What do I do when I have a number outside of the brackets? That's right. We bring it in. So we're going to try to do both in one step. What is 2 times x? 2 times negative 5? 2 times 3x?
90x.
And 2 times 1? 2. So, let's collect like terms. We'll bring the x's to the left, and we'll bring all of the constants over to the right. This will become 2x subtract 6x is equal to negative 2 plus 10. This will give us negative 4x equals 8. We bring the 4 over, so we divide by negative 4. X is equal to negative 2. Okay. So, that's everything we've done. Those are when the bases are the same.